Example 2. Write rational numbers in decimal form, but this time we're going to talk about repeating decimals. A class votes on whether to change their school mascot. How can you express the number of students in favor of a new mascot in decimal form? So again, we need to go over here to the picture. And we see that in a class of 18 students, 5 voted to change their mascot, which means the fraction is 5 votes to change out of 18 votes altogether. So writing that in a decimal form means division. 5 divided by 18, which in long division form you can see right here, they've already done the work for us. But this time, instead of getting a terminating decimal, we get a repeating decimal. A repeating decimal has a decimal expansion that repeats the same digit or block of digits, and there's no end at all. In other words, it forms a pattern of repeating digits that you can do over and over and over again. I compare this to the function on the computer that we call copy and paste. Because you could literally copy the digit or the block of digits and then paste them over and over and over again at the end of the decimal, and it would continue on forever in that direction. So what you notice here in the division is that the first number after the decimal point in the answer is a 2. After that, you continuously get the same remainder, and that remainder is the 14. And every time you have a 14, you bring down another 0. And so you're always dividing 18 into 140. And 18 only goes into 140 7 times over and over and over again. So once you recognize that you keep getting the same difference all the time, then that remainder will never be 0. Okay, that difference repeats. In this case, the difference was 14. Okay, so in the decimal form, 5/18 is 0.277, and then you've got those little ellipses. That's that 3-dot sequence there, and that means it does not terminate. So this set of 3 dots means, oops, let me see if I can do that, and so on. Oops, try that again. Okay, dot, dot, dot means and so on. Means it keeps on going. Or we can use a bar or a line over the digits that repeat to indicate that they do continue on. In this case, the digit 7 is the only one that repeats. So notice in the bar notation that the line is only on top of the 7. Now I'd like for you to look down at the try it question. In order to make the work more visible, I'm going to work out here on the side of the page on the whiteboard. You should be able to fit your work here in any of that empty space on your page. So let's take a look at the decimals that we will get for the fractions 100 thirds, 100 fifths, and 100 sixths. Notice in these fractions that the numerator is 100 in all 3 of them and is much larger than each of those denominators. We still set up the problem in division form though, where the numerator goes underneath the division bar and the denominator is on the outside. And then we're going to complete that division to determine if we have a repeating decimal or a terminating decimal. Try this on your paper or on a separate sheet of paper, and then come back to the video when you're finished to check your work and your answer. First, let's take a look at the first fraction, 100 thirds. When I divide 3 into 100 here, you'll notice that 3 goes into 10 3 times, which is 9. And when you subtract, you get 1. So you bring down the next number, which is a 0. And you get 10. And 3 goes into 10 3 times, which is 9. And there's still 1 left over. And then you have to add a decimal point to continue dividing. And after you add that decimal point, you bring down the next 0. And do you notice that every time I divide, I get a 3, and it's 9, and when I subtract, I get 1 left over, and the only number I'm ever going to be able to put here to bring down is another 0. So all of these are going to continue to be 3's. So the fraction 100 thirds is the same as 33.3 with a bar across it, meaning the 3 repeats. Now let's try the same thing with 100 fifths. This problem actually produces for us a whole number, or what we would call a terminating decimal, because 100 divided by 5 is 20. Now do the same thing with 100 sixths. And take a look at this one as I complete the work. 6 goes into 100 16 times, but there's still that 4 left over. So when I bring down my 0, I get 40. And 6 goes into 40 again 6 times, which is 36. And I still get a remainder of 4. And I still bring down the 0, and I've got 40 again. So right now, I've got the number 40, if you look here, 3 different times. And every time I divide, I have a 6. So I can stop doing the division because I keep getting the same remainder and the same number when I divide and put a bar across the decimal place where that number repeats, which is at the 6. So what questions do you still have about dividing to determine if a decimal terminates or repeats? If you don't have questions, then you're ready to move on to example 3. In example 3, we are asked to recognize rational numbers and to determine when we have terminating decimals or repeating decimals as rational numbers. So first of all, take a look at your 3 values in example 3. We have A, B, and C. All right. So in A, you have a decimal that terminates. How do I know that it terminates? It means that it has no repeating bar. You do not see that little ellipses or those 3 dots that say that it keeps on going, which means it is a rational number. So a terminating decimal is rational. In part B, you see that you have some repeating digits, 8 and 1. And there's a bar across the 8 and the 1. And because that repeats, it also is a rational number. But then take a look at C. In letter C, it doesn't stop. How do I know that? Do you see those 3 little ellipses? Those 3 little dots? Yeah, that means that it keeps on going. Okay? And I don't see any sort of pattern where it repeats. So it does not terminate and it does not repeat. The digits do not repeat. So it is not rational. A is a rational number. B is a rational number. But C is not a rational number. So think about those 3 examples. What makes a number rational versus a number that is not rational? All right, so some extra writing here. You can squeeze this in wherever you've got space on your paper, or if you just want to make a note to yourself, perhaps in the key concept on the next page, that might be a good place to add this in. Rational numbers are whole numbers, integers, fractions, terminating decimals, or repeating decimals. It includes all of those categories of numbers. Decimals that do not repeat or terminate are not rational numbers. So it has to terminate or it has to repeat in decimal form, or it's not a rational number. So now I'd like for you, last but not least on this page, is to take a look at the try it question here at the bottom. Take a look at these two numbers and decide if they are rational. What do you think? Pause the video while you think about it and then come back and check your answer. All right, I hope that we can read this, but I'm going to read it to you just in case. Your two numbers were negative, oops, and I forgot my negative sign there. Let's try that again. Negative 3/10. That number is rational because it does terminate. Okay, so you have that terminating decimal, which means there's no repeating bar. The decimal does not keep going because we don't see those three little dots. So we know that that is a rational number. The second number, though, is kind of tricky. Okay, here's the second number. I put a little star above it in the try it. So when I look at that number, the tricky part is that I see a pattern. I can predict what comes next in those three little dots in that pattern. But what we don't have is a block of those digits that repeat. In other words, I can't use on a computer a copy and paste function over and over and over again because the pattern changes each time. So in this pattern, we have a 1 and a 4. In the second group, we have a 1 and then 4 4s. So there are 2 4s. In the third group of this pattern, we have a 1 and 3 4s, and then a 1 followed by 4 4s. So I could continue this pattern and say, well, the next group would be a 1 followed by 5 4s, and then a 1 followed by 6 4s, and so on. So there is a pattern to it, but what we don't have is that repeating of a block of digits, which means this is not a rational number. All right, so taking a look at the key concept, I've done some highlighting and I've given you a little bit of an extra hint here. Okay, so I've shown you what it looks like when you have to do that long division. To convert from a fraction form to a rational number to the decimal form, you have to do that division. Remember that the denominator of the fraction goes on the outside and the numerator goes inside. Typically, if you have just a fraction that is in its simplest form, then the numerator is smaller than the denominator, which means the numerator is going to be under that bar, like you see here in the fraction 3/4 or the fraction 1/6, and the denominator is on the outside, which is why all of your decimals are less than 1, because those fractions are also less than 1 whole. So at this point, I want you to go ahead and raise your hand, and we'll get you your calculator. And then we're going to try some of the problems, making sure that you are setting them up correctly and using division correctly to find the decimal equivalent of each rational number. So let's go ahead and try questions 4 and 5. Pause the video while you do that, and then when you're finished, come back and check your answers. For part A of number 4, we're simply dividing 7 divided by 20. And when you do that on your calculator, you get 35 hundredths. So 35 hundredths is the other name, the decimal name, for the fraction 7/20. Now when you get to part B of number 4, you'll notice that the fraction has a negative sign in front of it. So as we type this into the calculator, we're going to need to indicate that our answer is negative. Okay, so put a negative sign in front, and then divide 23 by 20. And you get 1 and 15 hundredths. So the decimal equivalent negative 1 and 15 hundredths, is equivalent to the fraction negative 23/20. Now let's do the same thing in part C. 1 divided by 18 And we get a decimal that fills up the display of our calculator. Looks something like this. And it keeps on going. So the way that we write that is as a repeating decimal, which means we put a bar across the digit or block of digits that repeats. In this number, the only digit that repeats is the 5, not the 0 in the 5, just the 5. So this is how we write the repeating decimal that means the same thing as 1/18. And in part D, again, we have a negative fraction here, negative 60 over 22. So as we divide, we know that our answer is also going to be negative. And we divide 60 by 22, and we get 2.7272, and so on. Again, this one continues, fills up your display on your calculator. So we see that there is a pattern of digits that repeats. So we are going to write this using that bar notation to indicate that we have a repeating decimal. This time, though, both the digits 7 and 2 repeat, so we need to make sure that the bar goes across the 7 and the 2. Now let's take a look at question 5. There are 5,280 feet in a mile. What part of a mile, in decimal form, will you drive until you reach the exit? So here we need to look at the sign. The sign tells us how far away the exit is, 1,000 feet. So when we create the fraction, we have 1,000 feet to go out of 5,280 feet in a mile. That's the fraction that we're changing into its decimal form. So do that and then come back and check your answer. And you probably got something, again, that is very long, fills up the whole display on your calculator. And it keeps on going. So now we have to make a decision. What is it that actually repeats? Because that's where the bar notation comes in. So I start with my 0 and my decimal point, because bar notation is only used on the digits after a decimal point. I see the first two digits are 1 and 8. And that's the only time I see the 1 and the 8 in the decimal number. So those two digits do not have a bar across them because they don't repeat. After the 8, I see a 9 followed by a 3, and another 9, and another 3, and 9 and 3 again. And that's the pattern that keeps repeating. So the bar is going to go across both the 9 and the 3, but not across the 1 or the 8. Now that we've tried some questions together, it's your turn to try some on your own. Let me know if you need any help.